morning. So in previous lectures, we have detailedly discussed different concentration terms which include molarity, molality, normality and even mole fraction. These concentration terms was defined for solution. Solution is a homogeneous mixture of two or more substances. And in our syllabus we are discussing of binary solutions. But there is different situations in which we have to manipulate the solution. We would like to dilute the solution. Let's say in a laboratory, in a chemistry lab, you will be having concentrated sulfuric acid in the bottle. Obviously for different experiments you have to dilute it. In one experiment you may need to add 1 drop of sulfuric acid to 100 ml of water, or in some other experiment you may need to add 5 drops of sulfuric acid to 300 ml of water. So based on our requirements we may need to dilute a particular solution. So in dilution, how does the molarity going to change? Similarly, how will the normality change? That is what we are looking. So in dilution, how will the molarity changes? So what is principally the process of dilution? Dilution means in a solution we are adding more solvent. Let's say you are taking a 500 ml of beaker. You are taking 500 ml beaker. Initially you are adding 100 ml of water to it and you are adding a tablespoon of salt, NaCl. You are adding a tablespoon of salt in it. So initially the solution consists of 100 ml of water and a tablespoon of salt, which is the solute. And now I need to dilute it. For dilution, what should I do? I should add more water to it. The capacity of the beaker is 500 ml. So I can add much more. I can add 100 ml more, or I can add 200 ml more. Let's say I am adding 200 ml more water, which means I am now, we have 100 ml before and extra I am adding 200 ml. So now net total amount of water will be 300 ml. But I am not adding the solute. Solute was 1 tablespoon of salt which was added previously. So dilution is simply the addition of solvent where there is no change in the solute amount. And that is the basic thing you should know. Dilution means addition of solvent. There is no change in the amount, that is number of moles of solute is not changing in process of dilution. Let's take. So this is, you are studying how will the amount of solute or solvent changes when we dilute a solution. So the first principal point or the key point is that there is no change in the amount of solute. We can say number of moles of solute is a constant. In dilution, the amount of solute, that is the number of moles of solute, is a constant. That is the key point. And you know what is the equation for molarity? Equation for molarity is number of moles of solute by volume of solution in liters. Molarity is number of moles of solute in 1 liter of solution. What is the number of moles of solute in 1 liter of a particular solution? Obviously you know that in case of dilution, number of moles of solute is not going to change. So I can write number of moles of solute is a constant. Technically from experiment or from the equation side we can say it. So this is number of moles of solute is a constant. When number of moles of solute is a constant, molarity into volume is a constant, because molarity into volume is number of moles. Number of moles is a constant in dilution. So molarity into volume is a constant. Let the constant be K. So when molarity into volume is a constant, I can write M1V1 is equal to a constant and M2V2 is a constant. Okay. So finally I can write M1V1 is equal to M2V2. That is the product of molarity and volume before dilution is equal to the product of molarity and volume after dilution. That is product of molarity and volume before dilution is equal to product of molarity and volume after dilution, which is a very important equation which we use to analyze the molarity of a solution after diluting. So we have an example. Let's take, you have a beaker. The beaker I am taking 1 liter of H2SO4 in the beaker. This is a 1 liter H2SO4 solution where H2SO4 is a solute and water is the solvent. So this is an aqueous sulfuric acid solution and the volume is 1 liter, that is the net volume. And initially I am saying that it is having 2 molar H2SO4. 2 molar H2SO4 is initially. Okay, that is the molarity is 2. And now I am diluting it. That is, I am adding more water. Dilution means addition of solvent only. There is no change in the solute amount. So I am adding more water and I am diluting that solution. Initially I had 1 liter of aqueous H2SO4. Now I am adding more and more water and diluting it. I have made it 2 liters. That is, the excess 1 liter is simply from water. I am adding only solvent, which is water. So it becomes 2 liter. So now what will be the molarity? Initially when it was 1 liter of solution, molarity was 2 molar, and when it becomes 2 liter, what will be the molarity? And that is the question to us. Obviously you know that this problem can be done with the basic equation M1V1 is equal to M2V2. Okay, M1, what is M1? Molarity of the initial solution, and M1 is 2. Okay, molarity of initial solution is M1, which is 2, into initial volume V1, that is 1 liter, which is equal to M2. M2 is the molarity that we have to find, that is molarity after dilution into the volume after dilution. Volume after dilution is 2 liters, which is provided in the question. So molarity after dilution is 1 molar. So to connect molarity before and after dilution, we can use simple equation, that is M1V1 is equal to M2V2, and this equation was derived based on the concept that on dilution the number of moles of solute is a constant, only the number of moles of solvent is changing on dilution. Simply saying, on dilution we are adding more solvent. So now let's focus on how will molarity change when we mix two similar kind of solutions, that is mixing two similar kind of solutions, that is similar solutions. How will molarity and normality changes? That is acid plus acid or base plus base. How will the molarity change? For that, let's consider an example. Initially, let's take a beaker. This be beaker A. We have another beaker, that is beaker B. Beaker A is having 1 liter of HCl. Okay, and this is 2 molar. 2 molar HCl, and the net volume is 1 liter, that is aqueous solution. Okay, aqueous solution of hydrochloric acid. Aqueous. Okay, and this is having, let's say, 3 liter HCl. Aqueous. This is 3 liters. And let the molarity be just 1 molar. Okay, 2 molar means 2 moles HCl in 1 liter of HCl solution. Molarity is number of moles of solute by volume of solution, that is number of moles is, let it be 2 mole. So 2 mole in 1 liter of HCl solution, that is aqueous solution. What does it means? 1 mole in 1 liter. Okay, HCl solution. This is molarity. So I am initially taking 1 liter of HCl, which is 2 molar, and in beaker B 3 liter of aqueous HCl solution, which is 1 molar. Now if we mix these two beakers, we are mixing the content of these two beakers. Let this be beaker C. So I am mixing the entire content. So that is 1 liter plus 3 liter solution. 1 liter hydrochloric acid solution plus 3 liter hydrochloric acid solution. What is 1 plus 3? So this will be 4 liters. The net volume will be 4 liters because volume can be summated. The summated product will be volume. When we mix 1 liter with 1 liter, 2 liter. Similarly, when we mix 1 liter with 3 liter, we will get 4 liter. So I am having 4 liter of HCl solution, aqueous solution. But what will be the molarity? What will be the molarity of beaker C? And that is what we have to find. Will the molarity be the same, or if it will be changing, up to what extent the molarity is changing? So let's look. For that also we have a simple equation. The equation is simply M1V1 plus M2V2 is equal to M3V3. Similar to our dilution itself, but we have, since we are adding the solutes, here what is happening in dilution, only the solvent was increasing, the solute was constant. That is, in diluting, what you are doing, you are adding more solvent to a solution. but here you are mixing two solutions. Okay, you know that in first solution you are having a particular number of moles, in second solution also you are having a particular number of moles of solute. Okay, and you are adding both the moles of solute, that is the solutes from beaker A and beaker B is added. So obviously the net number of moles of solute is the sum of number of moles of beaker A and beaker B. The number of moles of beaker C, that is number of moles of solute of beaker C, is equal to number of moles of solutes of beaker A plus number of moles of solute of beaker B. I will write number of moles of solute of A plus number of moles of solute of B is equal to number of moles of solute beaker C. Right? The sum of number of moles of beaker A and beaker B will be the number of moles of solute in beaker C. So from this I am writing M1 V1. M1 V1 is number of moles of solute in beaker A. M2 V2 is number of moles of solute in beaker B, and M3 V3 will be the number of moles of solute in beaker C. So from this we can write M1 V1 is equal to M2 V2 is equal to M3 V3. So let's find the answer. You know that M1 is 2 molar and the volume V1 is 1, okay, plus M2 is molarity is 1 into, okay, this is 2 into 1 plus 1 into volume is 3 liter is equal to M3. M3 is what we have to find, that is the net molarity of the solution after mixing. And what is V3? V3 is V1 plus V2. This is V1 plus V2, that is volume is a summative product. So volume of beaker A plus content of beaker A plus volume of contents in beaker B. So that is 1 plus 3, that is 4 liters. So this is 2 plus 3 equal to M3 into 4. This is 5. 2 plus 3 is 5. 5 by 4 is equal to M3. What will be 5 by 4? 5 by 4 is 1.25. Okay, which is equal to M3 1.25 molar. So this is the net molarity after mixing. So to find the net molarity after mixing of two similar kind of solutions, we can use the equation M1 V1 plus M2 V2 is equal to M3 V3. Okay, where if it is given in the question the normality, we can just change the equation as, in case of normality the equation will be N1 V1 plus N2 V2 is equal to N3 V3, because you can substitute normality with molarity if in the question it is normality provided. So simply in questions if molarity is given, you can directly use M1 V1 plus M2 V2 is equal to M3 V3. And again you are using the concept, the sum of number of moles of solute in the two beakers before mixing is equal to number of moles of solute after in the beaker that is provided after mixing, that is number of moles of solute of A plus B is equal to number of moles of solute in beaker C. This is the concept.